Today, I would like to talk to you guys a little bit about kind of the serverless developer experience. So we talk a lot about building serverless applications, how to architect them, how to design them from an architectural perspective. But a lot of times we don't take the time to really talk about what does building serverless applications look like from the programmer's perspective, from the perspective of someone who writes code all day. And that's really the goal of this talk is to kind of take a look at what that looks like, and within the context also of using IntelliJ as an IDE, and how those kind of pieces fit together, and sort of how your world changes when you move to a serverless paradigm. So to kind of kick things off, I think it makes sense to start from something familiar. So I'm not sure how many people out there have used Lambda or have used serverless in the past, but we'll go through and kind of set the stage a little bit here. And I think it's helpful to start off and take a look at, what does it take today to build a simple web service? So we've got clients that are going to send us HTTP requests, and we've got to write some code to be able to fulfill these. So a pretty simple kind of initial architecture that you would probably start with would be, okay, I'm going to write some code in my framework of choice. I'm going to deploy it out to an EC2 instance. I'll probably have a database as well. And this is great. It's pretty simple, straightforward. I'm sure everyone has built something like this in the past. But then eventually, you start to get more users, more traffic, and you need to scale up. So that's pretty easy to do when you're in the cloud. You can always deploy more instances. You can put your code out onto these additional instances, stick a load balancer in front. Now we can kind of scale horizontally to handle more and more load. Now, of course, the problem with this is typically your load is not going to be constant. So you're going to want to be able to scale in as well as scale out. And so you would typically do that by implementing something like an auto scaling group so that we can automatically kind of create and terminate instances. So you're not paying for all of the capacity that you need at peak 100% of the time. This really allows you to kind of scale elastically and save some cost for running your infrastructure that way. And then kind of the final step would be making this highly available. So we want to make sure that even in the event that an entire data center gets wiped off the planet by Godzilla or something like that, that our application is still able to run. So that's simple enough to do. Again, we can spread our instances across availability zones. You can configure that through auto scaling groups, and that's all pretty easy to do in this kind of an architecture. And so we end up with this architecture where we've got a load balancer, we've got auto scaling groups, we've got instances, we've got our database, and this is a super common kind of way of building applications. This is something that thousands and thousands of customers have deployed. We see it all the time, every day. We work with customers all the time on building these things. But the problem with this is that in addition to actually building and writing your core application code, and in addition to building the application that you really care about, there's all of these other considerations you have to think about when designing this application and deploying it. So you got to figure out, how are we going to check the health of our nodes? How are we going to define the policies that decide when to scale out and scale in? We've got to deal with operating system and runtime patching and all of these other kind of things. And what's really interesting is when you look at this list of concerns on the right, there's not a lot of difference between the best practices used to solve all of these problems between all of our different customers. So if you look at, customer A and customer B, they're probably going to address a lot of these issues on the right in very similar ways, even though the piece on the left, their actual application code, may be very, very different. And so anytime we kind of see something like this, where there's a lot of commonality between the solutions that are actually being used to solve these types of problems, we ask ourselves, is there a way that we can make this easier? Can we make this better? Is there a way to remove some of this undifferentiated heavy lifting from our customers? So if we kind of go back and take a look at that initial architecture and really look at the essential components of what's happening here when we have this this kind of simple web service that we've built, and you start to take it apart piece by piece. First of all, you've got an event. In our case, this event is an HTTP request, but basically this is just something that happened in the world that we now need to be able to respond to. Additionally, we have a backend. In our case, it was a database. And then really the core of our application is this code that's kind of marrying those two pieces together and deciding, okay, anytime there is this new HTTP request, anytime this event occurs, how do I take the information from that event and then use that to access this backend in some kind of particular way. And you can imagine this kind of generalized pattern can happen in a lot of different scenarios, not necessarily just a RESTful web service like we're looking at, but there's a lot of different cases where this might be applicable. And really, this is the exact same kind of architecture that AWS Lambda uses. So Lambda is essentially a service that allows you to run code in response to events and connect to any different, a broad variety of different backend services. So you can write code in a number of different languages and then hook that code up to a number of different event sources. These could be anything from an HTTP request like we were talking about, or it might be, hey, there's been an update to one of the database tables that your application uses. And so every time that a new record gets added to this database, you want to fire some code off to go and handle that and update some other system. Or it could be that, resources in your cloud infrastructure changed. Maybe someone made a change to a security group, or someone changed something about your IAM policies, and you want to automatically go and run code to, potentially remediate a security issue, or validate those kind of changes or something like that. So any of these different types of events can trigger a Lambda function, and then those functions have the ability to interact with databases, object stores, other on-prem systems that you might have. Basically anything that you can get to over the network, your code can access. So this really is, at the end of the day, very similar kind of paradigm to the way that we've always built services and systems. It's just taking away a lot of the heavy lifting around all of those things that we looked at on the right side of that list of all of these different kind of concerns that you typically have to think about when deploying code and designing these systems in order to make them highly available and scalable. Lambda takes care of that for you, and you just focus on writing the actual code. So when we talk about serverless, so we've taken a look at Lambda specifically, but I think it's useful to really go in and kind of define what we mean by serverless. So serverless is kind of a buzzword these days. There's a lot of different people that talk about what it means and what it doesn't mean. But when AWS says something is serverless, there's really kind of 4 key characteristics that we're really talking about. First of all, there's no servers to manage, which might be kind of obvious, but the idea there is you never have to worry about provisioning or maintaining the actual underlying operating system itself. So you're never going to have to do operating system patching. You don't have to worry about updating the version of the runtime or the JRE or what have you. All of that's kind of taken care of for you, and you work at an abstraction layer that is above the concept of an individual server. The next on the list is flexible scaling. So this idea that you're able to scale your application according to the units of work that are relevant to the workload itself. So instead of having to think about CPUs and memory and disk space and these kind of server-based concepts and trying to map, okay, well, I'm going to have 1,000 concurrent users, and that means I'm going to need 4 servers that have this many CPUs, etc. Really now you can think about things in terms of the total number of requests, the total number of invocations, the amount of time it takes you to serve a single request, and your application will scale in those terms. And with services like Lambda, it's going to scale completely automatically for you. So as you get more requests, as more people start using your site, all of the underlying physical infrastructure required to service those requests will be automatically provisioned and configured, and those requests will get routed appropriately under the covers for you without you having to think about it. Along those same lines is automated high availability. So like we looked at in kind of the original architecture, being able to disperse your application across multiple availability zones and ensure that you don't have any single points of failure is a very kind of important cloud architecture concept. When you're using services like Lambda and the rest of the serverless platform, you don't have to think about that at all. There's no checkbox even to say, I want this to be highly available. You don't have to think about availability zones or configuring that. It just is highly available out of the box, and there's really no way to turn that off. And then finally is this concept of no idle capacity. So this is really where you start seeing major cost savings from an infrastructure perspective when you move to a serverless architecture compared to a traditional server-based one. So basically, when you're using Lambda, you're only paying for the exact amount of compute time that you're spending to actually run your code. So as soon as your code returns, we stop running the meter basically on that code. So now instead of having servers that are sitting around idle waiting for work to do, which it turns out that in the majority of cases, many servers are sitting with a very high amount of their CPU cycles being wasted just sort of waiting for work to be done. Instead of paying for all of that capacity, that burden is now shifted onto AWS, and you only pay for the amount of compute time that you're actually using. Which means that you no longer have to think about sort of capacity planning in a traditional sense. You don't have to worry about monitoring CPU utilization and sort of planning for how are we going to manage the traffic that we're anticipating to our website or to our service. All of that is now no longer a concern that you kind of have to think about. So with that kind of stage being set, this kind of concept of what serverless is, what Lambda is, how Lambda sort of works, let's now kind of shift focus into the actual developer experience. So let's talk a little bit about what it looks like to build serverless apps and to write the code associated with that. So if anyone has kind of played around with Lambda before, you probably have started off using the AWS Management Console to write your first function. That's certainly what I did the first time I ever wrote a Lambda function. I opened up the AWS console, went to the Lambda page. There's a nice pretty text box right there that you can just enter code into. You can write code, you can run it, you can deploy it all right there from the console. And that's great. It's a fantastic kind of first time experience. However, I think a lot of people associate that type of developer experience with Lambda itself and think that that is the way that everyone builds Lambda functions. But when you think about it, that's really fairly, that's essentially equivalent in the server-based world to SSHing into your production hosts, editing some files on the prod server itself, saving them, and then bouncing the process. So, I don't recommend using this model of development, whether you're doing server-based or serverless development. And instead, you really need to think about moving into a different model. So, when you're using the console, there are a lot of limitations, I guess, when you're writing code and developing applications using kind of the integrated IDE that's part of the console. It lacks a lot of IDE features. There's no real kind of build automation mechanisms. It's difficult to manage environments in terms of having separate sort of dev, test, and prod environments that you can easily deploy across. There's no integration with version control systems. It's difficult to collaborate with teammates, etc. So overall, I think that's one of the big first steps in sort of moving from this experimental mode of, okay, I just kind of checked out Lambda and I've been playing around with it to now moving into a real live, okay, we're going to build actual production apps. So when we take a look at kind of what a developer environment really looks like, from that perspective, the first thing is you should be using an IDE like IntelliJ to write and edit code. So there's no reason to use sort of different tools than what you're used to in order to build the code itself. There's nothing particularly special about the Java code that you're going to have to write, other than the fact that you just need to write, a handler method that complies with a particular method signature. But other than that, all of the same sort of work that you do in terms of writing and building and refactoring code is the same, whether you're using Lambda or a server-based deployment model. So use the IDE that you're used to, use IntelliJ or whatever other tools you like in order to write and edit your code. Similarly, you should be using source control the exact same way that you do for every other project. Nothing about this kind of really changes when you move to a serverless model. Now, one of the things that does kind of change, one of the big things we'll take a look at here through the rest of this talk is doing testing and testing your code locally before you do any kind of deployments, and figuring out how do we actually build an effective test strategy now that we're running on top of an environment that we no longer control. So instead of being able to fully emulate kind of my production environment because I completely control everything from the operating system up, now with Lambda, it's a little bit different model where that entire runtime environment is managed for you. And so being able to emulate that locally is sometimes a little bit of a challenge for new developers. And so we're going to talk a little bit about how to best manage that. And really that kind of ties into how do we deploy then our applications into a test environment, and then ultimately into our production account as well. And how do we kind of create this repeatable process that we can use through all of the different environments that we're working on, whether it's our local workstation or laptop or IDE, through to a development kind of sandbox account, and then all the way out into production. And then finally being able to kind of test those environments as well. So to kind of start this conversation, let's talk a little bit about that kind of deployment process, in terms of, okay, how do we actually get code from our IDE or from, after we've written the code, how do we get it out to Lambda? How do we deploy it to AWS in the first place? And that'll kind of lead us back to how we're going to build out kind of the rest of the tool stack in order to do local development. So if you're not familiar with Lambda, the way that you deploy code there is fundamentally, first of all, you got to build it. You got to compile it into a jar or whatever kind of build artifact you need for your language. Then you zip that code up along with all of its dependencies, upload that bundle to S3. Then you also need to create and update an IAM role. This is what kind of gives Lambda the security permissions it needs in order to access other resources. Then you make a call to the create function API in the Lambda API, and then finally kind of set up any event source mappings that you want to configure in order to have your function run in response to various events. Now, if you add in things like Amazon API Gateway or DynamoDB, which again, we're not getting into a lot of the details around the architecture, but these are services that are commonly used in concert with Lambda that provide API management and persistence or database access. If you've got these additional components, there's even more steps that you've got to deal with in terms of creating the actual API, setting up additional kind of resources and methods within your API, and creating all of the mapping there. And so you're starting to see that, okay, now it's starting to look like there's a lot of different tasks and a lot of different steps that need to happen in order to get kind of code moved into my AWS account. And it would be nice if there was a way to more easily automate this and make it a repeatable process for deploying across various environments. And so whenever we talk about kind of how do we repeatably create these types of cloud environments across various different accounts and in different regions potentially, we use this term called infrastructure as code. So infrastructure as code is really about being able to define a declarative template that defines exactly how your application, how all of your cloud resources need to be created, and then using a service that can kind of generate the actual physical resources for you from that definition. So AWS CloudFormation is the service that you would use to kind of implement this type of model. CloudFormation allows you to define a template in either JSON or YAML that defines all of the different resources that you want to create. So all of those different pieces that we were looking at previously in terms of the API, the function, the role, the database, all of those pieces can be defined inside of a template. And then you can push that template to CloudFormation and have it automatically create all of these resources inside of AWS for you. Now, if you take a look at what that really, so now if we take a look at what it would take to define this kind of an application. So this is a very simple serverless application that has kind of a single API endpoint backed by a function with the database behind it. And we look at the CloudFormation template for that. It's pretty complex. So the idea here is not for you to read all of this, YAML code here, but the idea is to just show that, there are still a number of different resources there. It's not a particularly hard template to write initially, but it's definitely not particularly easy to maintain, not particularly easy to read. And so it'd be really nice if we had a better way of kind of defining this, because when you're building serverless applications, there tend to be a number of kind of different little pieces of resources that you need to stitch together. And so using just raw CloudFormation to do that becomes fairly tedious and verbose. And so in order to address that issue, we've created an additional kind of tool that sits on top of CloudFormation called the AWS Serverless Application Model, affectionately referred to as SAM. So SAM provides this higher level of abstraction where you can define the functions and the events and all of the pieces that go along with that in a much more concise syntax. So instead of that previous CloudFormation template we looked at that had all of those different resources explicitly defined in a separate resource block through hundreds of lines of YAML, this is the SAM version of that exact same template. So you can define the exact same application using SAM, and here basically what you're able to do is define the function itself. So in this case, we're calling it getHTML, and then within the properties of this function, we simply define things like where our code lives within our local file system. We define the policies at kind of a high level, what security policies need to be applied to this function. And then SAM will manage under the covers, creating the appropriate roles and attaching all of the policies underneath that to make that work correctly. And then you're able to define event mappings directly in line with your function. So instead of having these be kind of this separate thing that's getting defined outside in your template, SAM allows you to define all of this inline, which makes it a much more kind of concise experience and much easier to sort of manage over time. So really, when you think about SAM, think about a declarative model for defining how your serverless application is structured and how it gets deployed. And there's two kind of core components to the serverless application model. The first is a CLI that runs locally, and the second is kind of an extension to CloudFormation itself that allows CloudFormation to understand these higher level resources and translate them into those underlying kind of raw templates that we took a look at. So just very briefly, I don't want to spend too much time getting into kind of all the details about SAM CLI and CloudFormation, but fundamentally, one of the key kind of components that the CLI provides you is this ability to very easily kind of package and deploy your code. So all of the details around how do you zip up your code, how do you create that deployment package, how does it make its way out to S3 and get versioned, and then updating those links within your template, all of that piece is now managed by this CLI tool. It's very easy to automate, very easy to integrate in with your local build process. And so now you can use SAM CLI to package all of your code, upload it to S3, and update your template. And then once you actually deploy that template, CloudFormation will actually transform what we looked at previously, so that nice, clean, simple, concise SAM template actually under the covers ends up getting converted into that big, verbose, raw CloudFormation template. So it's still using all of the same primitives that CloudFormation provides and all of the nice features around repeatable deployments and automatically rolling back in the event of failures and all of these kind of nice features that CloudFormation includes. But it's just giving you sort of this syntactic sugar that you can use to define more easily the structure of your serverless application. So now we can go back again, take a look at this kind of full stack deployment steps that we had talked about previously. And instead of having to do all of these pieces, now a full kind of deployment with SAM is simply a SAM package, SAM deploy call. So we're basically able now to bundle and deploy our application to any environment, whether that's a development sandbox that we want to use just to see kind of a current in progress version of our code and be able to play with that in real time, or if this is our actual production rollout. It gives us this very nice, simple, standard way of building and deploying our code across various different environments. So speaking of environments, this is one of the other kind of really, I think, key concepts within a serverless environment that really changes probably from most developers' perspective. So previous to adopting a serverless model, I know that for me personally, I very rarely did external deployments of my code throughout the course of a normal day. So when I was writing code, I was almost exclusively running and testing it locally. I'd check that in. There'd be some sort of CI/CD process that maybe would take that and deploy it out to a dev environment or a test environment. But honestly, in a lot of cases, that was only done occasionally anyway. Whereas in the serverless world, I think it's very important that you have the ability as a developer to deploy into a sandbox account yourself. And one of the reasons that that's now feasible to do, whereas it's not as feasible when you're using server-based technologies, is that you don't pay for idle. So we talked about that as being one of the key kind of components of the serverless paradigm, is that that there is no idle cost to deploying a Lambda function. You're only going to pay for it when it gets run. And so as a result, it's very feasible now to have dozens of different application stacks that are deployed out into various sandbox accounts, so that every developer on your team has the ability to go out and build and run kind of the full stack in a very production, an environment that mirrors production very closely. So there's a couple of different ways that you can approach that. You can either create separate sandbox accounts for each developer or use a shared account. Typically, I recommend kind of separate accounts if your company is good at managing AWS accounts. If you've got sort of the automation set up around creating, provisioning, and monitoring accounts, then there's no reason not to give kind of developers their own sandbox accounts, and let them kind of use those to experiment and stay isolated from one another. However, even if you can't do that, even if the for whatever reason you don't have the ability to create separate AWS accounts for each developer, using a shared sandbox account is still totally viable because of the way that SAM and CloudFormation work. You can deploy the exact same application multiple times inside of the same account, and those different stacks can all kind of coexist very easily inside of the same account. And so it's definitely possible to kind of manage shared accounts that way. You do have to be a little bit careful about making sure that you're not explicitly naming resources and things like that to where you end up with naming collisions. But in general, this is definitely a viable strategy. So now this same kind of process also then gets incorporated into your CI/CD process. So typically, as developers, this is another aspect of the world that we're sort of responsible for in one way or another. And so I think that the key thing to understand here is that when we talk about sort of shifting from a traditional development environment into a serverless world, there's the same principles of building a continuous delivery pipeline still apply. It's still fundamentally the same processes, the same steps that go into your pipeline. The only difference is just now, instead of using some sort of code deployment tool, or Chef or Ansible or something like that, that's going to go and push your code out to out to the existing infrastructure that already lives out there, you're going to use SAM instead to do the actual deployments of your application and update the various environments that you have. So really, it's just sort of swapping out the tooling that you've got, not really changing anything about the fundamental structure of how you're building and how you're developing software. So now that we've talked a little bit about deployments and managing environments and how that kind of looks using SAM, gotten kind of a crash course in what SAM looks like, let's talk a little bit about testing. So I think whenever we talk about testing in software, it's important to think through kind of the different hierarchy, if you will, of tests. So first of all, there's going to be some amount of local testing that we want to do, where this is very high velocity, make a little bit of a code change, see it run locally, kind of that green, red, green type cycle that you go through many times a day. Then there's also going to be this kind of remote integration testing. So at some point, you're going to want to actually deploy this out into an environment that more closely mimics production, so that you can actually touch and feel it in a little bit more realistic setting, and potentially have automated test suites that can be able to run against those. And then we also have an entire kind of automated integration test suite that's going to be part of our build pipeline. So this covers everything from kind of the automated tests that you might run in like a QA or stage environment, as well as any potential kind of smoke tests that we get run within your production environment as well. And so I think the key here again is looking at, okay, so what really kind of changes within this model? So within this diagram, where are the pieces that I need to think about how to do things differently when it comes to serverless? And really the only thing that needs to change fundamentally about your test strategy, I think, is how you're doing local testing. So again, because it's not as simple to emulate the Lambda environment out of the box by default on your own, because you don't control that sort of operating system and runtime and some of the event mapping machinery that exists inside of the service itself. You do need to think a little bit about, how are we going to structure emulating that environment when we're running locally. But once you sort of move into the cloud, once you've deployed your application out to AWS and you're actually running on the real Lambda service, now you're just interacting with your system via standard API calls or sending messages to a queue, etc. And so the way that you would test an application, whether the backend is serverless or not, should be using the exact same kind of tooling that you're used to for building integration tests on other platforms. So let's take a look at kind of the local testing piece of this. Now, the first thing that I always talk about whenever I work with customers who are building out kind of their first serverless application is to remind them that, just because it's serverless, just because it's simple, just because we're writing kind of within this functions as a service kind of mindset, and we've got these much smaller kind of deployment units compared to larger monolithic applications, doesn't mean that anything changes about sort of how we design code at sort of the OO design principles level. So whenever you're building a Lambda function, you need to kind of keep those pieces in mind. You still want to separate out the various concerns of a function, even though these might be very small pieces of code. It still makes sense to kind of factor your application according to the standard design principles that we've all learned over the course of a career. So typically the way that I recommend people look at this is to have kind of at least 3 different sort of layers within a function. The first would be the handler. Then you have sort of your business logic inside of a controller in the middle, and then services that you're using to interact with any backend services. So looking at these in a little more detail, the handler is really kind of responsible for setting up any function configuration, mapping any of the Lambda specific event structures that are getting passed into more business oriented object structures, and sort of removing any of the Lambda specific pieces of the data model that are kind of coming in the front door, and abstracting that away, so now that the rest of your system doesn't have to really understand anything about the specifics of Lambda. But very importantly, the handler method should not include any business logic. So oftentimes I see people that go in and write these handlers that have potentially hundreds or thousands of lines of code even in them, and that's essentially the same thing as writing a giant main method where you put all of your code into your single main method. You're not using any additional kind of functions or objects to abstract things out like that. And I think for whatever reason, developers often kind of fall into this pitfall of thinking that, oh, well, because it's Lambda, because it's simple, I don't need to kind of think about refactoring my code that way. But I think it's really important to do that. So then the next piece would be the controller. This is really kind of where the core business logic lives. And the important thing about this is your controller should be platform agnostic. So it should be super, super trivial to take an existing controller class that you've got and then wrap it with, say, a servlet, some servlet code to convert what used to be a serverless application into something that can now run inside a Tomcat or something like that. So you want to write your controllers in a way that they don't understand anything about the sort of Lambda execution environment. They're really just operating on kind of business level objects and concepts. And then finally, there's sort of the service layer, which just again sort of abstracts you away from any peculiarities of the backend services that you're integrating with downstream. So if you're willing to do this, if you're willing to organize your code this way, then it makes it very easy to write automated unit tests at the controller level that can test all of the really kind of core pieces of your business logic, the stuff that you're probably changing the most, the stuff where there's the most risk of getting things wrong. You now have this great sort of interface to test against and build a standard suite of unit tests using something like JUnit. And that makes it really easy then to test your code in a way that you don't have to worry about the Lambda runtime environment or worry about emulating that at all. Even though, as we'll see, we can definitely do that kind of piece as well. So then, there's also this question of debugging. So in addition to being able to kind of test your code, then there's a question, okay, well, what happens when I really want to be able to run my code and then something's going wrong and I need to kind of single step through all of the lines of code and figure out what's going wrong there. That can be somewhat challenging within the context of Lambda as well, because oftentimes we're used to this kind of model where we're able to deploy code out to some remote server and then use our IDE to connect to a remote debugging port and step through code regardless of where it's running. So that might be running locally on a Tomcat instance that's running on our own machine, or maybe that's running out in hopefully not production, but potentially a test environment or something like that, where we're having a hard time kind of reproducing an issue. And the problem is when you move to a platform like Lambda, Lambda doesn't allow you to open up those ports. So even if you could bootstrap the runtime environment itself and open up some kind of port like this, the Lambda service itself would actually block any incoming TCP traffic that's trying to hit a non-standard port. Anyway, so there's just no good way for you to kind of connect a debugger to a running Lambda process and kind of single step through code that way. However, using SAM CLI again, so going back to the SAM tool set that we talked a lot about how SAM can be used to do deployments, but SAM CLI also gives you this ability to emulate Lambda locally. And that's really the kind of big thing that we're going to take a look at here in just a second with a demo. But basically what happens is you now can author your code inside of your IDE, the standard way that you would think about it. As you make changes to your code, that can then be run inside of a Docker container that's actually managed by SAM. So the SAM CLI takes care of managing all of the event mapping and invocation code to make sure that your function code is getting run the same way that it would be run if you were running on top of the actual Lambda service. So then you can run an entire sort of system locally that's emulating this sort of standard Lambda runtime, and then connect the debugger to that, since now it's just a Docker container that's running on your local environment. So this gives you the ability now to get that kind of standard debugging model that we're all used to using without having to go and write a bunch of extra code to manage kind of the emulation of the Lambda runtime itself. And so one other kind of note to make about this sort of model of using SAM in conjunction with your IDE to run and manage and debug functions, we're actually currently working on a new AWS toolkit for JetBrains. So we'll take a look at that here in just a second, but I wanted to call everyone's attention to the fact that the plugin that I'm going to be using for some of the demos that I'm doing here is available right now on GitHub. It is still in sort of preview mode. It's really a developer preview at this point. So you still have to build it from source yourself. There's no installer yet. The documentation's a little light, etc. But we would love for anyone that's interested to go check this out, pull it down, build it, and play around with it. And please, any issues that you can submit, or if you'd like to go and submit a pull request, it's all open source. All of the development's being done in the open, and so we would really love any kind of community participation around this new toolkit if you're interested. So that being said, let's go ahead and switch over to our IDE and take a look at a really simple kind of example application. And we'll just walk through a couple of quick kind of examples of some of the features of using SAM in conjunction with IntelliJ. So just to kind of set the stage, so this is the template.yaml. This is the SAM template that I've been talking about this whole time. So we kind of looked at an example previously that's pretty similar to what I've got here. But the important thing to see here is that we've got a single kind of hello world function defined. I'm defining kind of where that deployment artifact lives on my local instance. So I don't have to worry about uploading this to S3 or managing that. SAM's going to take care of that for me when I actually do deployments. But I'm just kind of pointing to where Maven is actually building kind of my compiled source. So that is an important kind of distinction to understand. SAM doesn't do any actual sort of language specific compilation. So that's still going to be handled by, again, kind of the same tool chain that you're used to, whether you're using Maven or Gradle or Ant or Make or anything like that. You use the same thing to actually compile and build your code, and then SAM to really kind of package it up and do the deployment. So I'm defining that, yeah, I'm using the Java 8 runtime. I've got this environment variable here that we'll take a look at kind of how that gets consumed. But basically, yeah, environment variables are a common way of setting up kind of runtime parameters. This can be parameterized further. We could actually add this as a parameter to the template itself. So if we wanted to have different salutations in different environments as we kind of deploy things, then we could kind of manage that all through a single template. And then finally, I've got my event set up, and really the key here is that it's an API event. So again, this is going to use API gateway. We're essentially building a RESTful web service here. I'm exposing this at the /hello resource and handling the post HTTP method. So now if we go in and take a look at this handler, so the handler class that defines how to deal with each of the events that comes in is kind of defined here with this handler attribute. If we go ahead and take a look at the post hello handler, you'll see that this is a standard just Java class that implements this request handler interface that comes from the Lambda runtime package. So request handler has sort of an input event type and an output response type. And so then down here, I'm implementing the only method that's on this particular interface to take my API gateway proxy event input event and then return the response. And so this is a pretty just simple kind of serialized version of an HTTP request and an HTTP response. And then basically you can see here that I'm not doing a whole lot. I'm just pulling out the body, passing that down to this controller that I've created. So again, thinking about those different layers of my function, I'm doing all of my kind of function configuration initialization. So you can imagine here, I might, in addition to pulling out an environment variable, maybe I'm going to some configuration repository. So using parameter store or secrets manager or something like that to go and pull additional configuration data and kind of cache that up here, and then bootstrapping the controller classes and any other downstream services that I need. And then my handler itself is very thin. It doesn't do a whole lot. It knows how to kind of parse, or at least how to interpret the semantics of this, this input event object. So I'm not doing anything around the sort of business semantics, if you will. I'm not interpreting what the body means, but I am kind of pulling out the specifics, the specific way that this HTTP event has been encoded or has been serialized. Or I guess really deserialized in this case, so that now my controller class doesn't need to understand this API gateway proxy request event, which is very much a Lambda kind of specific concept. My controller can just operate directly on kind of the actual request body itself, which is more of a business level kind of concept, right? And then again, similarly, I'm going to build a response based on the actual raw greeting response that I return from my controller. I just build this response object which is very simple. I'm setting a status code of 200 and then adding the actual body itself and returning that. So from here, we can use the new JetBrains toolkit to run this locally very easily. So I'll take a look real quick at my run configuration so you can see how this is set up. So if you look at this new AWS Lambda section within my run configurations, I've already set up kind of this local hello world function that essentially just says, yeah, use the template.yaml local SAM template, and then I want to run the hello world function. So if I had multiple functions defined within this template, I could select those. It's going to pull this runtime and handler out of the template. You don't have to really specify those yourself, so it'll automatically kind of populate those. And then in here, really the kind of key piece is I can now define an event. So here I used one of these existing event templates from the API Gateway AWS proxy event type to kind of fill in all of this. And then I just went in and overrode the body itself to have my specific kind of request format. So you can see this is pretty straightforward. It's just going to have a simple name attribute within the body. So the body itself is going to be a string that is a JSON document that defines this name. I can save that and then come back in here and run my local version of the function. So now this is all going to be run via the SAM CLI, but sort of integrated in with IntelliJ. So now what's happening is it's going in, it's creating a, and of course it's going to hit an error. So it's going in and bootstrapping a Docker container to run this, to run my function locally. And live demo here, I got an issue. Looks like, yeah, it's trying to refresh the Docker image itself under the covers, and that's causing a problem. So what I will show you is, unfortunately, that is, yeah, that's not working right now. So instead of getting too mired down in that, what typically would happen is when you invoke this, assuming that it's able to reach out to Docker and kind of get this updated container image, which, yeah, there are some additional settings we can do to force it to not worry about that. But in the interest of time, I'm going to just kind of skip over that. But you would have seen sort of just the standard kind of execution and the result of that that execution being printed out here. We'd then also be able to debug this locally and single step through this breakpoint. But one of the other things that we can do that's pretty cool is actually emulate the full API. So so this initial kind of local run that I was trying to show you was initially intended to just use that document that we took a look at. So that actual event document that I was showing you in that configuration, it was going to send that event in to my code and run it just a single time against that. But in addition to running just kind of a single one-time invoke of the function, we can also use this same, use SAM itself, which I've already configured as an external tool, to run this full kind of API locally. So if I go and run this start API command, now the API is actually running locally on port 3000, and I've already got this this simple kind of web app. So this is just a super simple web application I built with React. It takes a name, it goes and calls my external service. So under the covers, we can actually take a look at this real quick. Under the covers, all that's happening here in app.js is I'm calling fetch here, right? So this is very simple. I'm just posting inside of the browser to this /hello resource. But now if I want to go and kind of emulate my entire end-to-end system and kind of see my application work, I can. So I can go run this. I'm getting an error because, well, again, because of the same Docker issue that I had previously. And so unfortunately, this demo is not working very well at all. We can probably, well, at this point, yeah, I kind of, I don't want to spend too much time trying to sort of live debug this. I apologize that I hit this. It was working right before I got on the phone. But I'll have to take a look at exactly what the problem is. Again, this is sort of still in a developer preview mode for the integration with the IDE itself. A few bugs still to work out, but you absolutely can. I have done it plenty of times with SAM CLI natively. You definitely have the ability to go and kind of run your application locally and be able to set up this really nice kind of tight test loop where you can quickly run tests against your against the code that you're writing as you're building new changes, see those changes locally without having to go through kind of a full external deployment process to send those all out to the cloud and kind of do a full-fledged deployment. So again, apologies for the kind of the demo snafu here, but if there are any questions out there at this point, those are the main things that I wanted to kind of show and talk about, but more than happy to answer any questions that folks have if you've got any. And I think you can probably just use the question section within GoToWebinar. If there's anything there, feel free to ask something there.
Oh, great. Thanks, Mike, for a great presentation. And I'll try to see what questions we have. Let's see. Couple of questions asked before you actually explained what serverless means, and I think those questions are covered. A funny question, unit or integration test? I think this is about preferences, right? Mike, would you like to comment something on that?
Yeah, I think that, so I mean, the way that I always kind of think about things is, you know, you probably want both. So I typically use unit tests primarily to kind of guide my actual development. So when it comes to kind of building software in a test-driven manner, I think it's really helpful to write very kind of small-scoped unit tests that define kind of just this small incremental change that I'm going to make. But then at the same time, from a regression perspective, from actually making sure that the functionality that the user experiences continues to work as we develop new changes to the software. I think integration tests are way more effective at kind of providing that type of regression coverage. And so I typically invest in building both. I think, yeah, it's oftentimes, I've found it to be most valuable to have a very kind of extensive suite of integration tests that actually hit my API using an HTTP client, sending kind of through the entire full stack, and now I can run that suite of tests in any of the different environments that I have in order to ensure that that the full end-to-end functionality is still working. Because I've definitely just over my career, I've gone through a number of different kind of philosophies on this, and this is where I've sort of landed at this point. You know, but I've absolutely experienced sort of this situation where we had extremely high test coverage, but everything was a unit test, and we did very, very extensive mocking everywhere, right? So all of our unit tests were written against just one single method or potentially just one single class, but then all of the other dependencies of that class were mocked down. And have definitely run into situations where you know, our mocks were not actually emulating the behavior of the systems they were supposed to be emulating, and as a result, you know, we thought we had a green test suite, but we actually had bugs that had been introduced because of kind of this mismatch between the way that we were mocking things and the way that the actual services behaved. So,
yeah, exactly. Another question, again, this question about serverless paradigm in general, and I see some other people also get confused about the term serverless. So there's a question, what it really means. Does it mean that there is no server behind?
Right, sure. Yeah, so that's a great question. So yes, serverless certainly does not mean that there are no servers. It really means that you are operating at an abstraction level above that. So you don't have to worry about the servers is really what we mean by serverless. So certainly, yeah, under the covers, there are servers in a rack somewhere that are actually running, running the code itself. But when it comes to how you build, deploy, and operate the systems that you've created, you no longer have to think about those concepts at all. So the idea of this underlying operating system, the idea of having to patch that, the concept of having to be able to scale dynamically, right? So one of the things that can get really complex when you're writing software that needs to be deployed on servers is, well, what do we do when we need to add another one? And how does that kind of get integrated with our load balancer, all of those kind of things. Like that automation oftentimes kind of blurs the line between kind of the developers and the operations team, depending on how you've kind of structured your team. So, but the whole point is now all of those different kind of concerns are taken care of for you. If you can just write the code necessary to handle each individual request. So, hey, I got an HTTP request. How do I handle that one request? Put that specific code, which is really kind of the important stuff that you really care about. If you can focus on building that, then basically the platform handles all of the rest of it for you. So that's really what we mean when we say serverless.
Yep. Another question about different environments. So how to build different environment for Lambda, like test, staging, production, and promote from the code to one of the environment to another.
Right. Yeah, so I guess so it's really important to understand that the way that CloudFormation works, the way that SAM works, is that you can take a template that we've created. So when I take, so let me share my screen again. So when I take a look at this template file, I can deploy this multiple times. So the idea is this is going to really kind of define the current state of my application. As I'm building out additional features, let's say add additional methods to my API, I'll define more functions here. As I'm updating my code and building new versions of it, SAM is going to take that currently built version. And again, if we're in a real like CI/CD pipeline, maybe this is part of my release process, so I'm not using the snapshot anymore. I'm actually bundling up kind of a released version of the software. But it's going to take care of that, upload that to S3, provide it with a hash of the actual contents of that file. So now I've got this sort of strongly named key inside of S3 that has the exact version of my code, and now I've got this template I can use to repeatably deploy that exact same version of that application over and over again. So I can deploy it to my developer sandbox account, I can deploy it out to a test account, I can deploy it to a prod account. And basically the idea is that the same kind of template is what gets sort of promoted and used as that primary deployment artifact, if you will, for migrating code from one environment to another. And then just the one other note that I'll make on that, when you're thinking about how to organize your various environments, the big thing, so there are a lot of different philosophies around how many different accounts should we have, how should we divide things up, should every environment be its own account? That's certainly one way to go. I think the most important thing, though, is you should absolutely have a separate AWS account for your production environment versus any non-prod environment. So if you want to use shared accounts for all of your non-prod stuff, for your stage and your test and your developer accounts and everything, stick all of that into one single account. That's certainly an option. There are pros and cons there. But the one thing that I definitely recommend doing is create a completely isolated production account that has different IAM users, has different sort of permission models, and that will really allow you to kind of ensure that you get strong isolation between production and the rest of your environments.
Cool. Moving on. Another question, is there any latency in loading the code with all its dependencies when a web request is received?
Sure. So there is the concept of what's called a cold start and a warm start. So basically, every time that your function is invoked, Lambda is going to do its best to sort of reuse the previous execution contexts that it has lying around. So basically, anytime Lambda runs your code, it's going to create what we call an execution context. You can basically think of that as like a container underneath the covers. Again, you don't have to think about that. You have zero control over how it's doing those pieces. But basically, once it's created one of these execution contexts, if it gets repeated requests to the same function, the Lambda service will reuse those execution contexts. So you don't have to reload all of the dependencies on every single request. But for, typically the data we have shows that it's less than 1% of invocations. On that small number of invocations where we do have to go and create a brand new execution context, we do have to download all of the code and dependencies and things like that. So definitely you want to make sure that you don't have a bunch of unused dependencies and you don't have sort of bloated deployment packages that have a lot of unnecessary cruft in them, in order to optimize the latency of those cold starts. But again, those cold starts typically represent a pretty small percentage of your actual invokes. And so oftentimes it's not terribly noticeable when you look at the entire kind of distribution of your latencies. But yeah, that is something to kind of think about and something to test. And it's going to be highly dependent on sort of how you're managing dependencies and what you're doing to bootstrap your function as well. Because there's definitely code that you can run in the initialization of your functions that can have an impact there too.
Yep. Does it make sense to implement serverless application with JVM-dependent languages such as Java, Groovy, or Kotlin? Consider the time required to start a JVM.
Yeah, so it turns out that starting the JVM itself is actually not significantly worse than starting like a node processor or a Python interpreter. If you actually build a complete no-op Java Lambda function and then a complete no-op node function or something like that, and you run both of those and time them, the Java one will be a little bit slower, but it's not significant. It's actually not too bad. What really gets slow in Java is all of the different frameworks and dependencies, and even things like the AWS SDK. So there are a lot of Java libraries that do a bunch of kind of eager loading and initialization of HTTP connections and kind of all of these other pieces under the covers. If you're using something like Spring, just sort of initializing the Spring container itself can take a long time. And so a lot of times people kind of conflate the dependency initialization aspects of Java code with the JVM itself. And so there's a number of things that you can do to kind of avoid that. So one is don't use things like Spring. I would highly recommend either looking at something like Dagger if you want a DI framework, or getting away from using a DI framework at all. Like honestly, it turns out that a lot of times you can actually write pretty straightforward, simple code by just using new. That's a different kind of discussion, but that's one option. And then also on the SDK side of things, so we are working on a new version of the Java SDK that's going to solve a lot of the latency problems that people have seen kind of with the current SDK. So I guess the upshot of that is absolutely Java is a great language to use for writing Lambda functions. You do have to be a little bit careful though, because a lot of Java libraries were not written with kind of the speed of launching them with kind of this interactive mindset in mind. But assuming that you kind of take care in which dependencies you take and how you manage the bootstrapping of your function code, Java is a great language to use. And in fact, once the containers are actually warm, Java typically outperforms many of the other languages. So you actually get better latencies with your Java functions on all of those 99% of your requests that are hitting a hot container. And so yeah, so oftentimes it's actually a really good idea to use Java.
Yep, cool. Moving on, can this Docker also emulate some external services such as DynamoDB?
So so there is a Docker container for running what's called DynamoDB local, and there's some work being done out there. I can't actually remember if this has been released or not, to be honest with you. I'd have to go check that. But definitely, yeah, some work being done to make it easier to run DynamoDB local next to kind of your SAM local invokes and be able to do that. And then, yeah, so DynamoDB is a good example of one where there is kind of an official Docker container. There's some other open source projects out there that also have kind of mock endpoints for being able to run other services locally. But honestly, in a lot of cases, so we talked a little bit about sort of integration tests versus unit tests. Even when running kind of local tests, typically I see a lot of customers who have a lot of success not mocking out things like DynamoDB locally. So basically taking the dependency on their internet connection and saying, you know what, our developers are going to need the internet in order to do their job, and we're willing to kind of take that dependency so that even when they run locally and they're running their code locally, they're actually hitting a cloud deployed version of DynamoDB or SQS or whatever the case may be. And again, that really ensures that you don't have any of that kind of mock drift, if you will, the difference between this emulated version and the real production version. And in a lot of cases, that can be that can really be a more effective way to kind of manage that. So I would encourage you to think about that. It's not right for every team, but oftentimes I think that's actually a much better way to go than trying to worry about emulating everything locally.
Yeah, great. So another question, who is using this sort of serverless workflow in production? Maybe LinkedIn, Netflix, some other companies.
Yeah, I think I'd encourage you to go take a look at the various case studies that we have published under. If you go to aws.amazon.com/serverless, we've got there are a lot of companies doing a lot of really cool stuff. So we've got everything from kind of born in the cloud, born serverless type startups. So A Cloud Guru that you might be familiar with, they run kind of an online training site. They've been built kind of from the ground up without ever creating a server. But then we also have, really large enterprises and government entities. You look at people like Fannie Mae or FINRA that are processing, billions of financial transactions every day using Lambda and serverless architectures. A number of different companies in the IoT space, a number of different people building standard sort of web services like we're looking at, and then also there's certainly a lot of people that are using Lambda for other kind of orchestration type workloads to build out their actual cloud infrastructure or shuttle data around between different big data and machine learning services, etc. So definitely plenty of examples of people using this in production.
Will this also work for Lambdas inside a VPC?
Yes, so you can definitely connect Lambda to a VPC. So I guess when you say this, so I guess I'll say a couple of things. So Lambda in general can run inside of a VPC. You can configure that when you create the function. You can configure that in your SAM template to define kind of the networking configuration that you want. If you are running locally though, so if the idea is, can I run my local function inside of the VPC? Whenever you're running locally, it's just going to inherit kind of your local machine's network configuration. So if you have a mechanism for VPNing into a VPC or setting up kind of that network construct from your local development environment, then you can sort of emulate that VPC notion. But there's no sort of kind of out of the box support, I guess, within SAM CLI itself for kind of connecting your local environment to a VPC, if that makes sense.
I see. Any planned support for or existing support for handling other AWS events? For example, DynamoDB streams. I'm not really sure what this question is about. Maybe Mike, you know.
Yeah, so we've got a number of, so there are ways that you can, so within SAM CLI, you can generate event skeletons, if you will. And so we try to make it easy for you to create kind of sample events that you can pass in yourself. But in terms of, being able to run like DynamoDB streams locally or something like that, or be able to hook up your local code to kind of a remote DynamoDB streams instance running in your developer account or something like that, that's not currently supported today. But yeah, typically what you would do is just kind of capture a set of test events and then use those kind of locally to run against your actual code. So
yeah. You already covered that to a certain extent. What is the best use case for these serverless technologies?
Yeah, I mean, there's a number of different use cases, I would say. I don't know that there's a particularly best one, but some of the really kind of the key ones that we see people having the most success with are one, kind of analytics types of workloads, so streaming data in. If you've got a large message queue or something like a um, Kinesis stream where you're ingesting a bunch of data like clickstream data or IoT data or whatever you have. Lambda is great at being able to kind of transform, manage the routing of and process all of these kind of small pieces of data that are coming in. So those are all events that you can think of. So that's a very event-oriented kind of model. Also building RESTful, APIs using API Gateway along with Lambda is a very kind of common pattern. And so we have a lot of customers now that are moving to that sort of model for building kind of RESTful APIs. And then, similarly along those same lines, just sort of backends for like mobile applications or again, in an IoT type of model where you need to be able to kind of respond to those kind of things, or even, looking at things like Alexa skills, right? So the majority of Alexa skills are actually built on top of Lambda. So all of those, I think, are really good kind of examples of use cases that serverless works really well for.
Yeah. Let me see. I think we ran out of time, and probably we have to wrap up.
Yep.
So we'll take a look at all the questions you've asked and try to make a follow up in the blog post, and also we'll be sending you an email with a recording and with the slides and probably with a link to the GitHub repository where you can see the source code. And yeah, we'll try to address these questions. I apologize that we couldn't answer all the questions.
Great.
That's it. I think, yeah, thank you, Mike, again for your time and for great presentation.
Yeah, absolutely. Thank you. Really enjoyed being here and appreciate the time, everyone.
Yeah, and thanks everyone who joined us today. We're looking forward to having you join us in the future webinars. So thank everyone and have a good day. Take care.